My name is Gene Kogan. I'm an artist and a programmer, and I come from a background of machine learning applied to music information retrieval, which is kind of what I was doing before I got more interested in computational and new media arts. My background is mostly in applied math, and I got interested in machine learning in college, and I began to apply it to problems in sort of audio signal processing. So classic MIR tasks like extracting the genre or the chords or the melody from music. And in that sort of ecosystem of people doing it, there's also a lot of interest in just tools for music creation. So I started getting into like MaxMSP and Pure Data. There's a lot of people kind of going in between the two. And eventually that led me to discover processing, open frameworks, started getting into like generative art, but always kind of kept doing these machine learning projects. That's a really hard question to answer because it feels like it's all the time, it's changing all the time for me, and it's just a long list of people who have inspired me. I've also taken a lot of inspiration from people like Rebecca Febrink, for example, who's been trying to make machine learning accessible to musicians and artists for a really long time. I think maybe as long as anyone I know who's been doing it. Other people who are community builders, so for example, Zach Lieberman, I've gotten to know pretty well, who made open frameworks and initiated open frameworks, and which has been for me a really big model of how to build community around arts, technology, resources. And so I get a lot of inspiration from people like that, and I don't know, way too many more to list. Machine learning, it kind of depends on who you ask it and what day. I think I find myself describing it differently all the time. It doesn't really have a fixed definition, but usually it applies to anything that we consider to be algorithms which attempt to give computers the ability to do what we perceive as learning in human beings. So getting examples and learning how to do certain tasks much better. And it really kind of grew out of things like computational statistics that came before it. Deep learning has been around, it really more or less means the subset of machine learning algorithms which are characterized by multiple layers, usually within neural networks, multiple layers of nonlinear data transformations, usually many layers. And depending on who you ask, they might just say it's a branding term or it has a fixed definition that means multiple layered neural networks. And it's become particularly prominent in the last few years because of a number of really promising results that it's achieved in this sort of number of benchmarks in speech and image processing, and more recently in natural language processing, which is one area that interests me a lot. But it's definitely a very interesting set of tools, and a lot of us have been trying to make sense out of it and apply it in different domains. So yeah, a lot of it is like using neural networks to create interesting correspondences between input data and some sort of like output data that's controlling, let's say, an art installation or something like that, in the most general sense, or a music performance or something like that. There's a lot of ways you can use machine learning in an artistic or musical context. So you can create interesting correspondences between sets of data. So like maybe you want to control musical instruments with your body or something like that. Or control create interactive art installations which are responding to some sort of real-time sensor data. That's in the real-time sense. And more recently, there's been a lot of coming out of the deep learning research, things which are not mostly real-time yet, but are really using neural networks to create interesting images and sounds and texts which resemble troves of data that they're trained on. For the most part, with the deep learning research, my own work has deviated very little from what's been demonstrated in the research, other than kind of almost like a mode of curation. So curating the research, or maybe putting it into novel contexts, or trying to use it to describe deeper concepts. But I think now you're starting to see a lot of those advancements that have come out in the last couple of years. They're leaking out and becoming part of bigger systems. So for me, both can happen. A lot of the times, especially recently with a lot of the most recent research, a lot of times it's quite unexpected. So when you read about it, you immediately want to just start experimenting with it from the bottom up, and maybe applying it to different sources of data. So for example, when Deep Dream happened a year ago, all of us were mostly just experimenting with it and just putting it onto images and maybe doing a little bit of training it on our own data sets, things like that. Sometimes it starts with a question. So for example, I've worked with Jeff Snyder on building these, or he builds these electronic musical instruments, and we want to be able to create unique, novel ways of playing them from the sensor input data that they receive. And so that's a really well-defined problem that we can apply machine learning to. And that's something we can, we look to machine learning in order to solve a well-defined task. And so you see I think for me, a lot of my work is coming from both ends of it. Sometimes it's sort of bottom-up experimentation. Other times it's looking for a particular algorithm which will analyze or solve a particular problem. I'm particularly interested to see where a lot of the new research going into natural language processing and computational linguistics takes us, because that's kind of the third domino to fall, after speech and images. And in a lot of ways, it's the most interesting one to me, because we communicate in language, and in the computational arts community, we were all really excited to see these, LSTM bots that were generating text, but they were kind of funny and incoherent for the most part. I think a lot of that will change when we start to make computers which are capable of understanding meaning or intention or reasoning in natural language. And I think it's going to fundamentally change a lot of the way that we interface with the web. And that's going to open up a whole new, can of worms. We'll have to ask about, if we're acting upon this information on the spot, what happens when it's wrong? How do we rectify that? How do we counteract whatever negative outcomes might occur from that? And that's also a very, I think, understudied problem, and I hope to see more people looking into it. And for my own part, I'm really interested in maybe helping people like journalists, for example. There's a big trend of journalists getting into big data. We see all of these huge sources of data dumps coming from institutions. This is a big low-hanging fruit, to try to make tools that will aid journalists in finding interesting bits of information in all these data dumps. And I'm hoping to maybe get a little bit more involved in this. That's part of the motivation for some of my work. And we'll see when we have a web that's really sort of that's able to understand semantics and language, and then I think it'll fundamentally change the way we interact with it, and I can see that being something in the next few years that happens. Well, I've been teaching for a long time now, so even when I was not just machine learning stuff, but I've been teaching kind of like programming classes and especially creative coding classes over the last few years. And this year, I've been doing a lot of short workshops or one class at NYU also on machine learning for artists, which is kind of a new thing for me because for the most part we didn't ever teach machine learning to artists before. Now there's a lot more demand coming from artists or people just involved in creative disciplines altogether, you know, outside of the research or outside of computer science. And that's been really exciting for me because this is exactly the kind of people that I think can benefit a lot from understanding machine learning. And it's been a really interesting process for me because you know, a lot of it is, you know, it's unclear how to teach machine learning to artists. There's not a ton of precursors out there. It's usually taught to computer scientists. So I'm a big fan of a lot of you know, open source toolkits which attempt to make it a little bit easier to interface with some of the deep learning libraries. So libraries like Keras and Lasagna. Keras, for example, is a completely independent library that's built on top of TensorFlow or Theano. And it kind of modularizes or encapsulates a lot of the common tasks that you need to do in coding, you know, experiments with primarily neural networks, deep neural networks. And it makes it a lot easier to kind of interface with it, especially if you're just getting started. You know, hiding some of the parts of it that aren't really necessary for you to be aware of, especially when you're kind of doing experimentation. In a lot of ways, it reminds me of like things like open frameworks, for example, which do the same thing for in C++ for creative coding libraries or libraries that are useful to creative coders. I really like Wekinator, which I've mentioned. Again, and it's not an organization per se, but it's a tool that is really useful for, especially for artists and musicians who aren't necessarily interested right away in coding, but want to integrate machine learning into their, you know, creative workflow. There's really not actually a ton of, you know, besides for the research institutions, there's really not a ton of organizations that are already out there. I would also, I mean, this is full disclosure, this is something that I'm involved in, but I'm creating, or I'm helping to create a list of, or a website which contains a lot of resources for getting started with machine learning, and particularly targeted towards artists or activists or people working kind of creatively with code, called ML4A, and it contains a lot of sort of resources and materials for learning about it, built on top of some of the things that I mentioned, like Keras and Wekinator. It's far from being ready, so it's not necessarily something worth looking into just yet. But I put my classes up there as well. But you know, anything that attempts to make this stuff more accessible to the general public or anyone who's interested in it, coming from outside of a computer science background, I'm usually a big fan of. I should also mention there's a lot of really great blogs, particularly ones maintained by people who are within the research. So Andrei Karpathy and Chris Olah, Michael Nielsen has written a really great book about machine learning. There's a trend of a lot of people actually writing about the work, especially in the creative context, and often providing code with it as well. And people are usually found riffing off of that code, and more people I find are doing so these days. And for me, that's a really encouraging thing. I think it actually feeds back into the research. And that was probably something that was undervalued, I think, by previous generations of researchers. I'd like to see more of this, and I hope to. Beyond that, there's not a lot of institutions that are doing this stuff. So, and I'm always inspired by bottom-up grassroots, open source communities, things like that are usually the ones that I'll support the most. And when you kind of just hack away at the code, you begin to develop a sort of vocabulary of different things that you learn about all of the different ways that you can make modifications to a sketch, and then before you know it, you're creating your own. And for that reason, this sort of permissive culture of people sharing code and allowing others to kind of more or less copy large parts of their code into their own work, I think creates a community around these tools, which is there's a lot of mutual aid. With the open frameworks community in particular, the forums to this day are incredibly busy and people are really helpful. And I learned a lot about open frameworks just by not even always asking questions on the forum, but just looking at what other people are asking and looking at the code that other people were sharing. And after a while, you just kind of start to make your own. And I think that that's like with anything. What do they say? 10,000 hours or something. When you do something enough, you are able to stand on top of the work that came before it. And with machine learning in the creative context, it's still, I think, pretty raw. And there's really not a lot of people, but it is increasing all the time. And the rate of people the rate of new projects that you hear about every week seems to be accelerating. And for me, that's really encouraging. I hope to see more of these communities form. Certain things remain consistent, and that's kind of mutual aid and sharing your work and keeping it open source. And those things, I think, always are what allow more and more people to get started. The thing in machine learning that takes the most time is training. It can take days even. And sometimes it's actually not even really feasible to do on a laptop or something like that. There's a whole class of algorithms called generative models, which in this context refers to neural networks which are not just that they're used in the production of an image like Deep Dream and Style Transfer, but are actually the outputs themselves are images. So things like variational autoencoders, generative adversarial networks. Those two are the most prominent, and combinations of those. What they're doing is that they are fed a really, really large data set, typically images, let's see, that we've seen mostly. It can be other kinds of media also, but what we've seen the most of this year at least has been with images. And they learn to produce new images that look as though they came from the training set but are totally synthetic. We're seeing neural nets which are able to hallucinate fake faces and fake characters and fake, I don't know, we've seen it used on so many different image sets, flowers and manga characters and letters. And that's really, really interesting because it takes this notion of generative art to this, into this space which it wasn't usually. Generative art didn't used to have so much to do with real-world data, and so now we're seeing a kind of merging of resources that we can pull from the real world and combine it with generative algorithms. And there's a lot of research being put into those right now. This new organization, OpenAI, which is this nonprofit pursuing a lot of research in machine learning and in the open, as they say. We'll see what they intend by that. But they're really focused. They have some of the top researchers from who have been involved in formulating these generative models. And there's just a lot of general interest in these, in particular from the generative art community and the creative coding community at large. A lot of my students are really interested in using them in their own work. And the bottleneck right now is data sets. We don't have a ton of really good data sets, but that's always changing. Well, so 5 years ago, I actually was already doing machine learning. So I think if I knew now what I knew 5 years ago, I would have been studying neural networks more, because at the time it was, I guess some people already knew this, but maybe 5 years ago, let's say 5 to 8 years ago, for me, I was told by all of my teachers that neural networks were dead, and they're kind of a dead end. And so besides for the obvious ones, like studying neural networks and learning Lua of all programming languages, collecting data sets maybe, creating more tools for easily gathering data sets, that's always the big bottleneck. The number of things that I'd like to be doing, but can't just because it's not easily computable, because of, data is not in the right, not in the right format. Yeah, I would say those, for the most part, are the big things. Otherwise, I actually don't think about the question too often, because, we are what we are. There's really no, hindsight is always 20/20. I think is, again, it's a cliche, but for me, I think it's a very good cliche. We're always kind of, you make the decisions you do based on the information that you had at the time, and I'm sure I'm making tons of mistakes right now that I'll look back on. But those are, yeah, if I absolutely knew and I could go back in time and tell myself to do those things, I would say get more data sets, learn more about neural networks, and learn how to code in Lua. Yeah.